Okay, I get cut off right in the middle of explaining our graphing of this compound linear inequality using the new methodology, which is to simply locate the left endpoint from standard form, and I'm going to use the bracket notation this time around rather than the old-fashioned notation, and then the right endpoint, again using the new notation, the parenthesis, and then we draw a line between these, and that's how we will do this from standard form though. Remember, only from standard form. So let's go do part B that way. First of all, we see little number, big number, less than symbols, so we know it's in standard form. So from there we can go and we can locate the left endpoint, and I'm going to use a parenthesis on that. I'm using a left parenthesis because this is the left endpoint. And then I'll go locate the right endpoint. That's a positive 5. I'll put a bracket on that, and I'll use a right bracket because it is the right endpoint. And then all I have to do is draw a straight line between those two things. And that is my notation for graphing that compound inequality. Part C, the first thing that I notice is this isn't in standard form. So the first thing I'm going to go do is I'm going to put this thing in standard form. So I'm going to put my smaller number on the left, my larger number on the right, my variable still stays in the middle, and then I see that the inequality points to the x in regards to the 3. So it points to the x in regards to the 3. So I put in the same thing, inequality that contains equality. With respect to the negative 4, it points out the negative 4. So I'm going to point out the negative 4. And now once I have it in standard form, it'll be easier to graph. Okay, now once I have it in standard form, now I can go ahead and graph it on the number line. So I'm going to locate my left endpoint right here at negative 4, and this is my left endpoint, so I'm going to use a left, and I'm going to use a parenthesis because this is not included. And then I'm going to go and locate my right endpoint, and I'm going to use a right, and I'm going to use a bracket because 3 is included, and then I'm simply going to draw my line in between these. All right, now moving on to part D. Part D, I see that I have on the left a big number and on the right a small number. And then I do have less thans. This is not an inequality that is going to have a solution. What this one says is that x is greater than or equal to 5, and at the same time that x is less than or equal to negative 2. I'm going to draw this above the number line to show you what's going on here. So negative 2 is right over here, right? Oops, negative 1. Negative 2 is right there. And so this one says that from negative 2 here, I'm going to go out that way. And then from here, which is positive 5, I'm going to start at positive 5, and I'm going to go over this way. Do you see any overlap there? Do they overlap at all? No, they don't overlap at all. So on this one, what we actually have is no solution whatsoever. And I think it's important that you actually see a no solution for an inequality as well, especially a compound inequality. And that's what they look like. So in standard form, for a no solution, what you're going to notice is that on your left you have the big number, and on your right you have the small number, which makes it a no solution. Okay, now we're going to go and talk about this new thing called interval notation. So our interval notation, what we're looking at for interval notation is the endpoints. And this new way of notating the endpoints when I graph these things, I have been showing you here. And those endpoints are going to be notated, and then we're going to take a snapshot of what you see on the number line. So here you see x is greater than 5, and that's how we would have graphed it on the number line, the big dark bold line there. And interval notation is going to take a picture of the left and then take a picture of the right. So on the left we say 5 and it is not included, so 5 and it's not included, and then comma, and where does it go? And it keeps going and going and going and going, and that's the idea of infinity. So 5 to infinity, and this is what we call an interval notation. Let's take a look at x is less than or equal to negative 2. So we graphed x is less than or equal to negative 2 by putting in a negative 2 on the number line with a bracket, and then it goes off this way, which is to negative infinity. So the interval notation says where are we on our left side? Well, on our left side, we're at negative infinity, and then it's going to go up to negative 2, and negative 2 bracket tells us is included, and that's the idea of interval notation. And we can do that with compound inequalities too. Where's our left endpoint? Negative 1. Is it included? No.